Thank you everyone for joining us today. We're here to discuss confidential computing and AI together with Hub Security's very own CRO, David Hochhauser, alongside Buland Khan, Dr. Dutta, and Arti Srinivasan. And we'll start our webinar with a brief introduction from each of our speakers, where we'll hear a bit about who they are and what their background is. And then we'll get into a bit of a deeper discussion on everything related to confidential computing, AI, and 5G. I'm very excited for this. At the end, we'll hold a short Q&A, like I mentioned, to wrap everything up. So if you have any questions, feel free to drop them below in the Q&A section, and we will get to them at the end. We have a very impressive lineup of panelists tonight, and I'm very excited to have them introduce themselves to you. Maybe we will go one by one, starting with Buland, followed by Dr. Dutta, Arti, and then lastly, David, who will say a few words to introduce today's discussion topics.
Okay, actually, let me, Shterny, I'll just interrupt. So I'll start first, only because I'm going to lay out the groundwork just to explain some brief background on it.
Sure, go ahead.
And that will help. By the way, if you hear a loud thud, they're cutting down a couple of trees in my neighbor's yard, so don't be nervous about it. Okay, thanks, Shterny. As I said, I'm Chief Revenue Officer for Hub Security, basically a company with literally a brilliant group of hardware and software engineers and tremendous expertise. We focus on protecting sensitive information. So welcome to what I think will be a fascinating discussion. I'd like to take my 2 minutes, though. The reason I wanted to go first is to explain why we're holding this session and really just to put a basic definition of confidential computing out there. So, why did we convene a session that covers literally AI, 5G, edge, IoT, and touches upon blockchain and quantum computing as well? I mean, they each have massive potential and are game-changing by themselves. But the amount of information and processing power from these technologies is exploding. 5G will bring the data faster. IoT is going to bring more of it from new sources. Cloud, edge will bring computing everywhere it's needed. And quantum computing, perhaps a bit further out, will increase computing power to an almost incomprehensible level. And underneath it all is AI and machine learning, kind of making sense of really this vast amount of information to help us mere humans make sense of it. But with that potential, as Spider-Man actually says, comes great responsibility. This rapid pace of new technology is kind of also bringing rapidly increasing security and privacy threats. So it really requires a whole new cybersecurity approach. And so literally, what are those security issues? Why is confidential computing mentioned as being critical to solving these? And what are the various approaches to confidential computing? So let me just give you kind of a high level definition, of confidential computing, and then kind of a brief example. Okay. One, there are really three pillars. You kind of have your protecting data at rest, you're protecting it in transit and in use. So rest and transit are really kind of the traditional areas of security. Protecting data and the applications, though, while they're being used, that's really the tough part, because you have the data in clear, as you're computing it. And so with confidential computing, it's kind of a new approach. It isolates the data, isolates the entire application, and puts it in a protective computing environment during the processing. Okay, and the only thing that you could do is accessible only by authorized code. Not, it's really invisible to everybody else along there. So, that's great, but what's the big deal kind of about what else can you get out of the confidential computing? Why confidential computing? And the best thing I could do is let me just give you kind of one quick example. My favorite one has to do with kind of multi-party machine learning. Think about genetic information. It's likely by far the most literally personally identifiable information that we have, and enormously sensitive. So if you take pharmaceutical companies or medical research centers, for example, Now they're going to run AI, machine learning on it for algorithms, but imagine if they can now share all of their repositories of genetic information. And they could run it on there. The power would be enormous. The challenge is it's all sensitive. And so none of the information from one medical center can actually be seen or viewed by the other medical center. And not even the algorithm can actually be touched or manipulated by any of them. So when you put them together, and by the way, even the operator will not be able to see any and touch any of this. So now you kind of get the benefit of them all being together. And collaborative all information, but everyone is isolated and no one can actually see the others, but you get the value of the results coming from everything. And that's the huge, enormous benefit. And if you think about it, I'm sure everybody could think out there, there are so many multi-party examples across just about every industry. I was already talking to somebody from the military before. There's a whole range just from there. Healthcare, finance has things about anti-money laundering and stuff that would have huge benefits across being able to do these kinds of things. So finally, you know, that's one key aspect is kind of the multi-party data sharing. General protection from cloud providers. You could put more sensitive information on there, just insider threats from your own IT groups, and really an increasing need to protect all of this information from applications that are processed, say, on the edge, coming in, whether from IoT devices or anything else. So I hope that kind of sets the stage a little bit and gives you some time. And I'll hand it back off kind of to Shterny to introduce the first speaker, and then we'll get into the discussion. Okay, thank you.
Yeah, thank you, David. Okay, so because we have a lot to cover, we're going to move a bit quick. Buland, do you want to start and introduce yourself, and then Dr. Dutta, and then Arti?
Yeah, sure. Thanks, David and Shterny. All right, so hello, everyone. My name is Buland Khan, and I have been in this industry, IT industry, for over 20 years now, of which I have spent initial 10 years in system integration projects, and the last 10 years have been in IT infrastructure advisory, consulting various different clients, helping them with helping the CIOs with their strategy roadmap consulting, and also developing a lot of new technology practices, like edge computing is one of them. I'm also a TOGAF certified enterprise architect and have worked across multiple industry verticals and enterprises like financial services, healthcare, retail, manufacturing, with a lot of telcos for actually a lot of global clients. And I am also the co-editor for Wipro's State of IT Infrastructure 2020 report, which is actually first of its kind neutral global research and thought leadership report. It actually provides a comprehensive point of view across the IT infrastructure domain, which is actually very relevant today. And if you all get a chance, please do glance through it. It's available on the internet. I am also a distinguished member of technical staff and currently heading the 5G edge computing practice at Wipro. Now, my charter is to create new offerings. It is also to build ecosystem and partnerships. That is like working with a lot of edge ecosystem players. Also to build and create the edge COE, monetize various IPs and use cases which are around 5G and edge computing. So today's topic of discussion is actually very relevant to the 5G and edge computing area, since we are seeing a lot of change in the architecture across enterprises, from code to cloud to edge. And as more and more data gets generated and processed at the edge, we see a need for securing the data. It becomes really critical. So I would like to thank Hub Security for inviting me to this panel discussion on this very interesting topic, and I look forward to a great interaction during the session. Thanks, and over to you, Shterny.
Great. Thank you so much, Buland, for a wonderful introduction. Looking forward to hearing more from you. I think Dr. Dutta, you'll go next.
Yes, Shterny, thank you very much. Hope you can all hear me. Good morning, good day, good evening. And I know people from all over the world are here. I'm so glad to be part of this important panel. I'd like to thank the Hub Security for inviting me and my co-panelists as well. So I work for Johns Hopkins University Applied Physics Lab. I'm a chief 5G strategist. I also teach a course, two courses actually, 5G and wireless security at Johns Hopkins University in Maryland. Prior to my job, I used to work for AT&T in Chief Security Office. So I had some experience in terms of how to build the requirement and get it deployed and make sure the end users are protected and network assets are protected. Before that, I had a little bit a startup stint as well, where I actually built a security monitoring system, company called Nixon, based in New Jersey. And prior to that, I had spent about 13 years in Bell Communication Research, became Telcoria Research later on. I got a chance to do a little bit of research and development, get involved into standards bodies, write papers, things like that. And then prior to that, I was at Columbia University in New York City in computer science department. And I worked there full time. I did my part-time PhD while working. If some of you are thinking about doing part-time PhD, let me know. I strongly encourage, but there are certain ways you have to get there. But it's worth it, by the way. So I have been working in the security area at least for last maybe 15, 20 years. In the last 7 to 8 years, when I started working for a security startup, I got involved in actually product development, how it can be deployed in operators network, for example, right? And then study the end-to-end security requirements. So if you are, let's say when I was in AT&T, we were doing 4G LTE networks, right? And now we started transitioning to 5G, and we started with SDN NFV, which is the software-defined networking and network function virtualization, right? And so there is an interesting way to think about the security from the very get-go. You cannot wait until things are deployed, architected, and think about security. That should not be the case. It was to happen right from the get-go and get the requirements, go to standards, build the stuff, bring in the lab, go back and forth, do the iterative process. That's how security has to be embedded, right? That's so important. And then, with Johns Hopkins, we have started looking into other aspects of 5G, right? It is not only operator centric. There are other verticals like education, public safety, agriculture, right? There are various verticals, I know AI, ML we are talking about as an enabler. So 5G compared to previous generation has a lot of new enablers, and that will enable new emerging application. And we'll talk about that as we proceed. And so while we take advantage of these enablers like edge computing, SDN NFV, other things like IML, orchestration, automation, analytics, Open RAN, etc. There are potential security issues, opportunities as well, right? So new challenges and opportunities. So how do we take advantage of the opportunities that comes with it? At the same time, what are the new challenges those are exposed, right? How do we take care of that? How do you look at the risk mitigation? Do we have proper security controls or not, right? So those are important things we need to discuss. And I guess this is an interesting platform. I'm hoping to be enjoying this and looking forward to your questions. Thank you.
All right, thank you, Dr. Dutta. Arti, you want to go ahead and introduce yourself?
Sure. Hello, everybody. Hope you're all keeping safe in these new and challenging times. And I really hope 2021 will be all positive and good. And I really appreciate you taking the time to come here despite all that's going on during the holiday season. So my name is Aarti. I am a product leader, a technology speaker, and a voice of customer evangelist. I have over 20 years of experience in product management. And initially it started with financial applications and modeling around that, which in those days we didn't have the AI bus, but later it was very much applicable to AI, and I've been in retail as well as in a startup which tried to build an AI platform. I have launched V0 to V50 products through various stages of development. I believe in the power of customer research, market research, and trying to get the solution to solve a real problem as opposed to just building technology for technology's sake. I'm very interested in this panel to approach it from a macro trend of how customers are needs are evolving with AI/ML workloads, as well as security needs around that. I am really excited to be here. Thank you for organizing Hub Security.
Definitely. Thank you, Arti. So now that we got the introductions out of the way, I'd like to jump into our discussion. And I have questions for all of you. I'm going to shoot them off one by one. If you have anything to add to another panelist's question, and once they're finished responding, feel free to contribute and to share. We're going to try to keep our responses to around 3 minutes, and because we have a lot to cover and a lot to get through. I'd like to keep some time for Q&A. So starting just with Buland, I'd like to throw the first question at you, which is, how are enterprises currently preparing for the adoption of 5G technology, and what are the primary cybersecurity challenges that need to be considered with its deployment?
Yep. Okay. So thanks, Tony. I think that's a very interesting question. Let me try and start with the first part on the enterprise 5G adoption. See, what we are seeing is as enterprises, they continue to rethink their connectivity and accelerate their digital transformation journey, right? We actually are seeing them investing in 5G networks with a specific focus on driving few things like digitization or accelerating their IoT adoption, and also kind of harnessing innovative techniques so that they can deliver enterprise connectivity. They can also kind of improve the productivity and increase their operational efficiencies. Now, the other thing that we are seeing owing to this growth of IoT and development of smart city initiatives, then your smart homes, smart industries, we are seeing that 5G has a key role to play, and it has a potential to offer reliable, high performance kind of solutions, right? And especially business and mission critical applications for the enterprise 5G. They will include a private network deployment kind of scenario, and also use cases which are specifically vertical or industry focused. So for example, use case in the healthcare domain, or use case specific to financial services or media and education. Uh, there are a lot of use cases which are being worked out for energy and utilities, for critical infrastructure monitoring management and things like that. For industry 4.0, for transportation or logistics and fleet management. So there are a variety of use cases which enterprises are exploring, which are around 5G, right? And which through which they could exploit the benefits of 5G, as we say, like ultra low latency and enhanced mobile broadband, which is ultra high speed bandwidth and massive machine to machine communication, right? And these we believe are just the beginning of the 5G digital economy, right? Which is actually going to be a hyper-connected world and full of possibilities. So that's the first part. On the second part of the question, so the primary cybersecurity challenges, right? Now, as 5G becomes more popular, the adoption rate of 5G enabled private network and some kind of a software defined WAN will also increase significantly. Now, enterprises would also implement variety of use cases, as I mentioned, right, which would leverage edge computing, right? So for these use cases to be successful, edge computing is going to be really critical. And 5G would also present more security risk, right? So as Dr. Dutta mentioned, right? And hackers would be able to exploit flaws in the 5G network as well. Now, with 5G, a lot of numerous different kind of heterogeneous devices would be connected, right? Right from your conventional devices used in enterprises to IoT devices, which are used in OT kind of scenarios, right? Or use cases, and also in commercial environments. Now, this would kind of increase the attack, and yes, and as these devices, these are, as we've seen, right, in a lot of these attacks and media as well. These are kind of often vulnerable to attacks, and organizations will have to actually invest more in securing this, right? From they will have to invest in securing the data, right? They will have to invest more for the vulnerability management, to increase those kind of capabilities so that they are able to prevent such attacks. And to tackle 5G related security challenges, right? So businesses, both businesses, enterprises, and network operators, also the telcos, we believe should adopt a security model which is actually similar to the public cloud security model, right? So where they are segregating between sensitive, non-sensitive data and things like that. So that is one of the traditional approach. Now, a conventional security approach may not offer adequate data security, especially when the usage would increase. Therefore, what we believe is organization will need to seek scalable and automated security solutions with AI and ML kind of a powered threat detection, and it also has response capabilities. So that is what I can think of, Shterny.
Yeah, thank you, Buland. And I think maybe Dr. Dutta can expand for us a bit on, build on what you just shared, and maybe tell us a bit about what 5G cybersecurity will look like and how its security will differ from previous generations.
Yeah, that's a good question. I also wanted to tell, I serve as a co-chair for IEEE Future Network Initiative, where we have about 15 different working groups, like we're talking about roadmap, right? One of the working group is security. We're looking in 3-year, 5-year, 10-year, how the security posture is going to look like, right? Look at the current landscape, how it's going to show up in 5 years and 10 years. So if you're interested, please look into the future networks, IEEE.org. But just to answer your question, Shterny, think about when we have to think about security, before even we get there, think about how 5G technology is different than the previous generation 3G or 4G, right? If you look at the historic evolution, starting with 2G, when we got into digital, you had GSM and then CDMA from Qualcomm, and finally 4G was born around 2010, right? 3GPP started developing the architecture. And most of the previous generation have been ramping the bandwidth, right? Few bits per second, kilobit to megabit. And if you look at the 5G, it added additional components like, we have massive bandwidth with high bandwidth, but massive sensing, massive control, massive reliability. I think Buland just talked about, probability or, how reliable this is. And this can be possible because of different types of enablers, right? And some of the enablers I can think of is, if you want to have a network reliable, programmable, flexible, you need to have software-defined networking, network function virtualization, right? If you want to have, to give proper end-to-end quality of service, 5G added things like network slicing, right? If you want to have orchestration, automation, ease of that, you added virtualization, right? Or orchestration. Buland talked about ultra low latency. If you want to support that, you have to add edge cloud or cloud computing. People have started putting the orchestration even in the RAN, the radio access network. How can you make it cloudify, right? And there are other things with AI, ML, things like predictive security, supply chain security, and data security, privacy, etc. They're also coming. So I call it more like pillars of 5G security. And then on top of that, open source, API, microservice, right? So if you look at the whole 5G core, it is going towards microservice-based, service-based architecture. We're getting rid of protocols like diameter, using HTTP, REST API, JSON, those kind of things, right? Things becoming more granular. So you have to open up end-to-end, look at all the interfaces, and think about these additional, I should say, enablers that we are adding, and what are the risks are getting added because of that, right? If I'm putting an SDN controller or I'm doing virtualization, what are the potential risks associated with those, right? We need to look at those challenges. So, in a nutshell, you still have to take care of the traditional networking, like putting firewalls, proper multi-factor authentication, things like that. But you're adding these additional knobs to take advantage of the 5G. So what are the potential security issues in each of those? We have to, do a complete threat taxonomy, look it up, open up the interface, look at the potential sources of attacks, and think about potential challenges and opportunities. I just stay there.
Yeah, I think that was a good summary, just a really brief summary. Thank you, Doctor. My next question is for Arti. It would be great maybe if you could give some of our listeners a bit of background on federated data. What is it and how will it be used? you'll need to unmute yourself.
I'm sorry, it's also a good segue into the chat question, which comes about the missing data. So let me first answer that and then jump into federated data. As we know, for AI workloads, data is very critical and it's garbage in, garbage out. So when there is missing data, there are many ways, and there's a whole area of research around how to train models without data. But in short, the answer for that would be you could either do like use a mean value or a zero value or a median value for that, or you could use a random value. And for the other option is you can actually use predicted values for something which is missing. So that kind of solves that question. So now on to federated data. Given people's data is very, very sensitive, there is two types of security for data. The first one I would say is in terms of modeling is differential privacy, which is another form rather than federated data. So when when your models need data which is anonymized or sensitive medical data, one option people use is they add noise to the data so that you don't know who it is or where it's coming from before modeling on it. And so that is more in the field of differential privacy. Whereas the federated data is instances where you cannot modify the data and you need to take it as it is for your models. A great example is is Google's phone. If anybody's using the Android type instance, each one is typing and you're getting your own personalized model for updating that completion of typing. So now the data, what you type is very secure. It belongs to you and it stays on your phone. But the model is updated based on that federation on each of the phones, which is then consolidated and sent to Google so they can update the model again for better improvement. So each of us owns our own data in our own, for lack of a better word here, enclaves or in our own devices here. And then you're sharing that the model is learning from that. And if the user opts to share it to improve the general good, then you're getting an updated model. This concept of customer owning the data and having a centralized model is also giving rights to hardware. David talked about like the homomorphic, he'll talk about it, as well as like the whole enclave mechanisms of hardware separation and security, right? So it becomes even more important when you have more devices that need to talk to each other, but you don't want to bring the data centrally. So the federated data is the ability to keep these data separate without the model actually knowing much about the data and protecting its privacy and security.
And what do you think, what do you believe that the role of federated data will be in the future of AI development?
I think it is very important. I have worked in healthcare applications, and one of the biggest thing is the HIPAA privacy, and which it should be, right? I don't want my medical records hanging around in the cloud or in the hands of a developer. So when you have this type of ability to secure your data and just still get benefit from the model, I think more sensitive problems will start using it. More healthcare research will happen in terms of you having this type of access to federated data.
Great, thank you. And I have one other question for you, which is related to edge computing, which I know is also part of your background. So maybe you can share with us a bit about what the current trends are in edge computing and how they relate to 5G.
Sure. So if you start talking at the macro level, in terms of cloud was initially we had like installation of applications and doing it on premise. Then we had the cloud. And now you have another version, which is AWS, for example, launched Outposts, which is giving you your own data center and co-located data center on your premise, right? And then the other piece of that, which is literally having computing at your on your device, without getting to the cloud. And that is the innovation in edge computing. So an example in retail would be like there's retail cameras in the warehouse, and I'm not comfortable sharing the data to any cloud provider. And I want to have all my models on identifying pilferage or some kind of inconsistencies in the warehouse. The camera has to have all the it has to have all the models and all the technology for doing the manipulation at the edge. And it has to be done at speed. As we all know, another example is the ADAS, which is the automated self-driving cars, which is another big research area in the edge computing field as well. So one of the things, as more and more move to the edge, there is in general a big demand for chips. There's a big demand for more investment in chips, like Intel bought Habana. There are other companies which are investing in these homomorphic chips, or chips which have the ability to think like a human at the edge. So that is one of the things I see where there's more acquisition and investments in the chips area. And in general, McKinsey is predicting that there'll be like 15% more increase in hardware spend in data centers across, irrespective of whether it's in the edge or in the cloud by 2025. And that's actually like a revival in some sense of making hardware cool again, if you think about it.
Definitely.
So the second thing is when you take a chip at the edge, you're literally bringing computer into your hand, right? So you have memory, you have networking, you have compute potential. So there will be investment in all the three areas of how you can do something quicker at the tips of your finger. So I would think there will be like low cost compute chips where that will be whether it's bringing a model onto your chips, like DNNs on chips or spiking neural networks on chips. Those are all things where we expect these big machines to be running these compute intensive jobs, but you're actually thinking about how do I bring that back to the edge and have those models on chips. And finally, like I said, the networking is another big aspect of it. So it's not just your device. So if each of us is um, carrying our own edge devices, or like each of us is driving our own self-driving cars, those have to talk to each other, right? Like, so one device has to be able to talk to the other device on the edge, and having this mesh kind of network where you're able to communicate is another trend I think will happen around the edge computing.
Definitely. And thank you for those insights, Arti. I think Buland probably can expand a bit on some of the security challenges that are related to edge computing.
Yeah, sure, Shterny. I think, yeah, so I kind of agree with Aarti. So we are seeing a lot of requirements from a lot of customers globally. And also a lot of telcos. We've started consulting a lot of telcos around edge computing and help them define their edge computing roadmap and strategy and things like that. And as I mentioned earlier, the success of 5G, right, it will be majorly driven by the use cases, right? And actually its adoption by the enterprise, right? And also from the consumer's perspective, right? And edge is going to be really critical to realize these 5G capabilities. As Aarti mentioned, right, it would actually help to enable faster insights, right? So if some action has to take place at the edge, right? So the data has to be processed and it had to be acted in real time, right? Now, edge in a lot of scenarios can also be used to perform offline operations, right? So it is not that the edge has to be connected all the time. So it can also perform offline operations. So what it means is that there has to be some applications and data, some part of the data, which can ideally be stored on the edge. So for it to perform the offline operations, right? Now, since by definition, edge computing is not centralized, right? So the edge of network deployment can be in exposed locations, right? When you talk about edge, there are a lot of different type of edge, and we are still discovering, right? So there is near edge, far edge, a device edge, enterprise edge, and now we have public cloud extension edge and third-party edge and things like that. But specifically talking about the far edge, right? So like cell towers or the enterprise edge, or the edge which could be placed at remote location for different kind of use cases. So for example, let's say for a oil refinery, there could be a edge which is placed across the uh, miles away in remote location, and which are not actively monitored, and it is not as secure as a traditional data center, right? Because there's no one to take care of your edge, right? So what we believe is with edge computing, the importance of data encryption is actually magnified. Now, due to the fact that edge computing deployments might not have the same kind of physical security like we discussed, right, in traditional cloud deployments or a traditional data center kind of thing. Now, an attacker could potentially steal a hard drive also from a remote location, or they could also plug in a USB key to access the data. Now, we were consulting one of the telcos a few months ago, and they had exactly the same problem. So they were kind of exploring, should we put a lock in the compute edge node or physical lock, or should we kind of put some HSM modules and things like that? Now, that is not feasible, right? Putting a lock is still okay, but putting HSM modules and things like that, managing all those things, it's not practically possible, and across various different locations, right? And especially Dr. Dutta spoke about ORAN kind of scenarios, right? So with 5G, and due to the nature of spectrum of 5G, there would be high network densification and disaggregation on network. So which means now if we have thousands of these cells our sites, tomorrow it is going to be 10x. Now, how are you going to manage the security across all these 10x sites, right? So it is going to be a major nightmare. Now, the other risk with edge computing is that the traffic is generally flowing over untrusted public network, which is also kind of can pose a high risk. And what we are also seeing across the industry, there are not well-defined process in place to deal with these kind of regular patching and emergency security issues, right? And given that the edge computing, as Aarti spoke about, right, it can potentially involve a large number of distributed and heterogeneous devices, right? So edge, when we say, it is not just a hardware, right? So it could be a device, and device could be of any nature. It could be a IoT gateway. It could be actually x86 server. It could be a device edge as well, right? Someone spoke about a mobile or a tablet, right? Then you might have other different platforms or operating system, um, which are part of the edge, the hypervisors itself, the containers. Now, a lot of these applications are built based on microservices architecture, right? Then the applications which needs to be deployed on the edge so that it can act, right, for providing real-time insights. There are a lot of API which are getting developed. So how do you secure all of them, right? So the patching and data security of these components can pose different kind of risk. So one of the top challenge for edge computing, which we believe, is actually a lack of common security framework today, right? And in my view, there is a need for consensus of on best practices for edge computing, and also a well-defined security framework which can take care of these risks and mitigate them.
Definitely, I think I see a lot of nodding heads. I think that there's general consensus around this, that there's a lack of direction and a need for an outline about the real challenges that we have ahead of us. So I'm just going to follow up on some of the security challenges that you've outlined. In what ways do you see confidential computing helping us overcome some of the security challenges that are related to edge computing, and as well as cloud security?
Okay. So I think okay. So we are all seeing, right? So data is getting generated all across, right? And it's the new oil, and it is also the most important asset. And protecting sensitive data in all its kind and all its states is actually have become more critical than ever. Now, organizations that handle sensitive data, like there could be organizations in the financial services, like credit card data, or in the healthcare, as Aarti mentioned, right? Now, their information need to, I mean, this health information or credit card data information, it needs to mitigate threats that target the confidentiality and integrity of either the application or the data in system memory. Now, today, if you talk about the existing security or the traditional security, we say that data is often encrypted at rest, right? Which is actually in the storage, or in transit, which is across the network, but not while in use or in memory, right? So it is really important, I think. So with these kind of new technology trends coming in, like edge computing, it is really important to protect sensitive data even while it is in use, by enabling confidential computing and extend edge and cloud computing benefits to these kind of sensitive workloads, in my view. So basically, what we believe is this confidential computing, it can protect data in use by performing computation in hardware-based trusted execution environment. I think David spoke about it. So which are basically to secure and isolate environments. It can also help to prevent unauthorized access or modification of applications and data when they are actually in use. So when these kind of encryption, confidential computing is actually used along or together with data encryption at rest and in transit, it would offer exclusive controls of keys, and it could also eliminate barriers of moving sensitive data or data which is highly regulated, right? So which has to meet certain compliance. And also application workloads which are flexible from today's on-premise, which is kind of inflexible, to a more flexible and modern, either to the edge or cloud platforms, right? So I think confidential computing, it could enable end-to-end security encryption for data at rest, data in transit, and also the data which is in use, and thereby increasing the security level of organizations and enterprises and increasing their trust levels as well. Yeah.
Shterny, I would also add to that, to what Buland said, some of the important points he said about having a consortium. There is an effort called like confidential computing consortium, where it could be at different layers, right? Like the security could be at your hardware layer, where it's your keys are secure and encapsulated there, or it could be at the hypervisor layer, or more at the container layer. So there's no standard saying this is the best architecture for your particular application. So it's good to see that there is a consortium and they started working on it with the Linux Foundation, and trying to get this to market soon, like for open governance. And you can see that it's still in like research, I would say, in some sense, where there's no winner saying this, if you only do it in the hardware enclaves, that's the successful path, as opposed to only doing it at the containers, that's the successful path. So it's still like up in the air, but I'm glad like we are starting to talk about it soon.
Yes, thank you. I've heard about this project as well. Excited to see what comes out of it. Thank you both, Buland and Aarti. I would like to ask another question to Dr. Dutta. As there already is inbuilt security measures for that organizations can take advantage of when it comes to their 5G cybersecurity, what are some that you would recommend to organizations to explore and to look into, and which ones exist already that can be used and leveraged?
Yeah, sure. I think, I'm enjoying the discussion, by the way, Aarti and Buland. This is very interesting. You're really giving a deep view of what's going on, and we're just scratching the surface, by the way. We should have multiple of these panel discussions. So when to answer your question, Shterny, when you look at evolution of a new technology, right? you have to think about whether glass is half full or half empty, right? You cannot, you have to look at both sides. So you look at the 5G and beyond security, you branch it off, right? And see, okay, one side is glass is half empty. That means, I have lots of new challenges coming up. I'm adding new enablers, new characteristics, MIMO, millimeter wave. On the RAN side, I'm virtualizing stuff. I'm adding network slicing, SDN and MP, etc. Right? So that are potentially, or edge computing, and Buland talked nicely about edge computing, and so as Arti, some of the challenges I need to take care of. But at the same time, when you look at glasses half full, it does provide some 5G enabled security, and I call them opportunities in terms of providing resiliency. I'll give some example, maybe one or two example, lack of time. So I call it security as a service, and if you try to put this together, and either there is a denial of service attack happening, either on a control plane or data plane, the billions of devices trying to connect. Either they're malware infected, botnet type attacks. They might be sending lots of attached requests in kinds of IoT devices, for example, or they might have malware infected, sending lots of traffic and jogging up the bandwidth and doing lots of bad things on my network assets. And things can happen from roaming providers, from Wi-Fi, from the internet side, right? And we can do a complete threat analysis. But so that's one type of overwhelming the network assets, right? The other thing could be real performance related overloading. So these kind of things happen. How can we take advantage of these characteristics, things like data analytics? You have an orchestration, let's say ONAP from Linux Foundation, OpenMana from Etsy. You have this SDN controller that has the ability to program the switches, routers, firewalls on the fly, right? And then you have these security functions. Either it could be intrusion detection system or intrusion prevention system, or some kind of a security monitoring from different vendors. And traditionally, since we moved away from the monolithic proprietary systems, you can really buy this security function or virtual security function from different vendors and dynamically service chain that, right? So, and this is one opportunity where if you see there is an attack happening, how quickly you detect and how quickly you figure out what kind of attack, is it a TCP attack or SIP attack, or RTP attack, or from where it is coming from, figure out the details. Then you have the ability to program these firewalls on the fly, right? So in a way, you have this closed loop automation, and depending on where do you want to put it, do you want to put it in the RAN to do the edge security detection? Do you want to put it in the edge? Or do you want to put it in the core, right? How quickly you want to detect and mitigate. So that's just one example of how you can take advantage of security function virtualization, SDN, and do some kind of a security detect and mitigate quickly enough, right? And I talked about this is mostly on reactive security. You can still take advantage of the predictive security by using some kind of a AI ML techniques, looking at the behavioral patterns. So zero trust type attack, zero-day attacks, right? Before even attack happens, it's going to happen, you stop it. So that's one specific advantage. That means the resiliency, scaling up the network, scaling down the network. If there is an attack taking place, I think people call it recover fast, resolve next. But you can do both things at the same time. So when the attack is taking place, you still want to provide the quality of service to the other people. So you have the ability to scale up and scale down the resources while you are figuring out who is attacking it and mitigating it, right? So that's one advantage of the, some of the things you put together. And if I know we have lack of time, but you can do the same thing going over some of those cloud RAN, for example. If you're doing open RAN type deployment, your opportunities are like you are increasing the programmability, right? You can embed your DDoS detection mitigation functionality at the edge. You can do dynamic resource scheduling, correlation of control plane, data plane traffic. You can do it right at the edge, right? So those are some of the opportunities that come with Open RAN. And similarly, I know we talked a lot about the edge computing. Edge computing itself also provides some inbuilt security, right? You can embed security monitoring at the edge. And I know my previous speakers talked about, I call it side channel attacks, right? If can I detect them because things are getting virtualized or containerized? If I'm handing over from one edge cloud to another edge cloud, how can I reduce the latency by having proper security mechanism, right? So that's something to do with the mobile edge cloud. And similarly, if you go further with slicing, slicing itself gives you some kind of a granularity of security, right? You have priority service, you can put them in one slice, and non-priority type, non-mission critical, you can put them in a different slice. So that way, in a way, you're providing some kind of a security demarcation by doing, putting a different type of application, different slices, but that also exposes some challenges with slicing. One slice, one UE may be connected to multiple slices, slicing impersonation attacks, things like that. And then, think about, I'll give another example of SDN controller, right? So SDN controller, obviously, it provides the resiliency I spoke about, programmability, adaptability, can do service and different security functions. But then what are the potential risks associated with that, right? You are dealing with northbound API, southbound API. Can somebody do protocol fudging attack? Can somebody, do impersonation attacks? So whole SDN controller can be completely overwhelmed with bogus requests to, control the firewalls, routers, etc. I mean, I just give like 4 different examples. So you can think about similarly with API security, open source, supply chain security, what other things you need to think about there. I think I'll just leave it there for lack of time. I know Arthi Buland, they talked about virtualization a little bit, with hypervisor, what are the potential risks there? You need to think about what are the potential mitigation techniques, while virtualization gives us the ability to put multiple multi-tenant type application on the same common off the shelf hardware, right? How do we take care of the VM to VM attack, right? Or application attacking a VM, or they call it VNF catalog, right? Where you have multiple VMs and you're orchestrating VMs, putting different placement of VNFs. So some of those these are mostly on API based attacks that we have to think about. Yes, I'll leave it there. I know, Shterny, we need to move on, right? So
no, I think that was super fascinating. I just wanted to stop you, and I think that at the end of the day, I'm here to discuss cybersecurity, and these are some really helpful tips. I think that many.
Yeah, I mean, that's true. I mean, I just want to, maybe a last thought I'd like to say. At some point of the time, I don't know if you have any specific question for me. There are some kind of a best security practice, and getting involved in the consortium forums that Arthi mentioned is important to have collaboration among researchers, practitioners, operators, vendors, application developers, right? And when you look at the network, like 5G network, let's say, open it up, there are so many different interfaces. We look at the 3GPP document, there are about 30, 40 different interfaces, like N1, N2, like that. And these are all microservice based, but most of them are HTTP, REST API stuff, right? So you really need to open it up, do a threat taxonomy, look at the points of attacks that might come from different parts of the network. And then you create some kind of a threat taxonomy, put them in a different kinds of attack category, like the loss of availability or loss of confidentiality, integrity, loss of control, malicious insider. I think David talked about it, theft of service. And you put them in category and then see, if I'm a hacker, how do I go and do bad things? Can I flood an interface? Can I crash a network element? Can I do some kind of a fudging attack or something in my code that might just completely knock down the HSAs? So you think about that, then in terms of attack, you see, how can I do that? Can I send lots of attach requests? Or can I do man in the middle attack and chain the SIP headers to make it look like coming from somebody else, right?
So many different
things like that. Yeah, and then come up with a mitigation technique and look at the controls you have and look at the risk factor. You come up with a risk factor. What is the risk if this happens? And then you augment your control, right? This has to be an iterative process. I think that's what is important.
Definitely, and I think that's why these topics are so complex, and because there's so many verticals and factors to take into consideration, and that's why we're glad that you guys can make it here today and discuss these topics with us. Super crucial. We have just a bit of time left before we head to Q&A. So just a reminder for our audience, if you have questions, now's the time. Put them in the Q&A section and we will get to them very soon. David, my next question is for you. Thank you so much, Dr. Dutta. My next question is for you, David. We hear about different approaches when it comes to confidential computing, such as homomorphic encryption. Can you clarify what some of those approaches are for the layman?
Sure. Well, I'm glad I kept awareness the camera was on, because I think I switched to an attendee. I was just listening carefully. I was making some notes. I probably have 1,000 more questions, even for the other people over here, for another time. So yeah, some of the things that I was gathering, even, and I'll keep this fairly short, we've covered a decent number of them, is one, it's extremely dependent on kind of the use case as well. So we even saw the edge computing. I forget who it was listed, 4 different kinds of IoT types of devices. There's from industrial to consumer. So there's kind of a tiered approach as well. I've seen, use cases where, hey, you might do some IT, AI on the factory floor for the industrials, and then you're going to come for several different groups and roll it up into the cloud and do a whole nother level. Now, some of the edge things need to be able to scale that way. So you may end up needing, looking at different approaches. But to summarize, some that I've heard is obviously homomorphic, which is kind of encrypting, and there's pros and cons of each. For large amounts of data, I don't think homomorphic necessarily scales at this stage of the game. Obviously, there's a ton of work going on in those areas. Chip manufacturers like Intel's SGX, which is really kind of a homomorphic approach. People are hardening the chip from that perspective. There's Federated we've heard about, which is really fascinating, how the data kind of stays in place and then reaches it out. But one thing, and then there's kind of the whole platform of kind of integrating the whole thing and putting it together, a secure platform. It may not necessarily use a secure chip, but it may be able to, which is kind of, by the way, one approach that we take, is to look at it. How do you encrypt, make sure the data that's coming in is encrypted, the data that's stored is encrypted, and how do you protect and yet scale the amount of information that you're processing? So I'd say there's a whole range of different approaches in here, and I'll leave it at that, because I think each one of them could probably add an hour and a half to each of those. Again, and I'll leave it at that, other than to say, let's take a look at each of the use cases as well, because I think that in and of itself would be fascinating.
Is there any resource or place where people can get more information on a topic like this?
I mean, there are a ton of places, and I want to keep this more, in a sense, educational than product-centric. Well, one, certainly from the people on this panel, you could get more information. That I'm certain of. And it's starting, if you start look, you'll see different places. Of course, we'd be more than happy to discuss our approach with you, from that perspective. I think we have an enormous amount of expertise in this area as well. And as I said, we look at it kind of as one whole platform, but there's a whole range of areas along here. So that's where I would really say is feel free, if you're uncertain, contact us. We'd love to talk to you about it. And I'll just leave it, real brief at that, as I would say the people on here are phenomenal experts in this as well. And
thank you, David. Actually, if you'd like, one thing we didn't hear about too much is what Hub Security is doing in this space. So if you want, you can briefly explain what Hub has to offer in regard to 5G and cloud computing cybersecurity.
Okay, so I'll take 30 seconds since we sponsored the seminar, just to give you the little bit of the sales pitch. But I'll literally keep it to like 30 seconds for now. What we've essentially done is we've taken what an existing concept is, a hardware security module, which deals with an extremely secure environment for managing your crypto keys and all your crypto services. We've merged that with kind of a secure computing platform, so that what we end up with is an extremely secure platform that scales to be able to handle all sorts of computing power and it also it's compute power and AI, and to be able to run the actual application too. Our belief is don't separate the data from the computing, from the keys and from the crypto. Keep it, every time it leaves an environment, you now have an area of exposure. And so we've merged those two concepts together into one extremely secure, what we call Vault platform, that has isolated hardware enclaves, secure enclaves in each of the areas. That's what enables us to protect the applications and the data that are running, not permit anybody else, even if we're sharing the data, to see it, not even permitting the operator to actually see it. And we've put in a whole range of security mechanisms inside there, from secure hardware firewalls to prevent data from checking the data coming in and out. Be able to run full-scale artificial, machine learning algorithms, protect those particular algorithms as well. And kind of one area which didn't come up with as well is from make it quantum ready. In other words, there's a point in time where people are stealing your data now, and in 5 years, when quantum computing can handle it, they're going to they'll decrypt it at that stage in time. And so it's important to think ahead, is whatever you're putting in place, how do you deal with that to start protecting and thinking about protecting that information even at this stage in time. So that's kind of, in a nutshell, kind of the platform that we have, an extremely scalable, secure environment. And that's how we did it. We've literally merged the whole concept of a secure module with actually a secure computing platform. That was it. I won't get too much more into the sales piece, but hopefully more than happy to discuss that with people further.
Yes.
David, one thing I would say is, I know in your intro you talked about blockchain. We can't end the topic on security without talking about that, right? And so it's been getting initially a lot of bad rep about how much power the chips consume. And so if you have more breakthroughs with quantum computing, and also like thinking about private blockchains, that would be something on top of the encryption, which your homomorphic encryption, where your data is not exposed at all and it's encrypted even in compute. You can have the ability with private blockchains for corporations to do much more and effectively if it's sensitive data. So essentially, in summary, people don't need to worry about that much the purism of implementing blockchain in its original way, but take the concepts which resonate and combine it with folks like Hub in terms of making it more secure.
Yeah, good point. And it's getting the data onto the blockchain as well. Multiple aspects of that. You're right. I mean, that's actually could be a whole nother separate topic on blockchain and security as well. But thanks.
Anyone else would like to add something to that?
I think I'd like to just echo what David said. The hardware security is very, very important, right? You can knock it down right there. So anything we can do to improve that hardware security is definitely a welcome change. Hardware security, physical layer security, these are becoming very important.
Thank you, Dr. Dutta. So we're really short on time. Maybe we will just past the Q&A, maybe I'll ask you guys one more question and get your input on it. And then we'll wrap everything up. In terms of best security practices related to 5G deployment, what are your recommendations? We can start with Dr. Dutta. If anyone else has anything to add, feel free to jump in. And we have another 10 minutes before the Zoom cuts out. So,
I mean, I will start a little bit, then I'll give others to speak as well. As I've been answering some of the questions you asked me. It is important to analyze the end-to-end network. That means you start with your handset, your application, including operating system, everything, and look at how a whole 5G ecosystem looks like, right? I mean, you have over the air using new radio, millimeter wave type communication, sometimes sub 6 gigahertz, MIMO type, antenna steering technique. Then you have lots of these G node Bs because of densification of cell. And then you have this whole front haul, mid haul, back haul type because of the edge computing, edge cloud. Then you get into the core where you have a data plane, control plane, user plane. And then you see where the types of attack may happen, in the control plane, data plane, man in the middle attack, side channel attacks, API based attacks, right? And then you look at that, then you put them in I call it threat taxonomy, and look at the opportunities, what are the challenges, look at your controls, what you have. At the same time, it's so important to get involved in the the consortiums, 3GPP, IEEE, NGMN. There are many open source. I don't know, we didn't talk about those. There are many open source community out there. I know Linux Foundation is one of them. OpenNFV, OpenAir interface on the SDN controller side, you Open Daylight, ONOS, etc. Open Run Alliance coming up. So it's important to know what's going on there. Internet Engineering Task Force, 3GPP, ETSI, IEEE, and then this open source community. And finally, the important thing is to have access to a test beds, right? There are people are building the private test bed. Even in the United States, National Science Foundation has built 4 different 5G test bed based on open source in New York City, Salt Lake City, North Carolina, and they're building another rural broadband. So getting involved in those consortium where you can really try to do some proof of concept based on a specific use case are important. Only then you can see how things are working, right? It is not only architecture, PowerPoint slide, you have to make sure it actually works. And then, go back, things do not work, go back to standards and ratify that. That will be my kind of suggestion, right? Yeah. Go ahead, please, other panelists, if you have something to add.
Yeah.
Yeah, I can go next. Okay, so I think great point of view, Dr. Dutta. So I would like to highlight majorly on the edge computing side, right? The area that I am working on. And as I mentioned, right, so there could be various different kind of edge that I spoke about, and different kind of devices, right? And it could be heterogeneous edge. So right from the device, OS, containers, applications, APIs, and things like that. Dr. Datta already spoke about the data plane, control plane, security, and things like that, right? Now, since there are potentially a lot of these different kind of devices within the edge ecosystem and the 5G ecosystem, which is still evolving, right? What is most important, according to me, is the visibility across all these devices, right? So how do you implement visibility and control from a security perspective across all these devices, right? The second thing is how do you kind of do a threat correlation, okay, across these different devices as well, right? So that's also important. Third thing is even in edge and 5G, if we can kind of adopt a zero trust kind of a security model, right, for the edge clouds or private network deployment, that is going to be a great model to adapt or a framework to adapt. And as I mentioned earlier, right, there is a need for some kind of a security framework for 5G and edge both. And I think Aarti added that there's a consortium, right? So which is great. So that's it. What I would like to add from my end.
Thank you, Buland. Arti, is there anything you'd like to contribute to that?
I think not on that topic, but in general, I think I really enjoyed being here today and learning a lot by talking to these experts as well. So I really thank you guys for organizing it and making it a worthwhile discussion for everyone.
Definitely, thank you. And I hope we can have many more discussions like these in the future because they are critical and they're relevant now more than ever. We talk about 5G, we're talking about the future, but the infrastructure needs to be built and deployed today. So these are really critical discussions and we appreciate that you take the time to flesh them out for us. And with that, I will say thank you guys once more. Thank you to our speakers, David Hochhauser, Buland Khan, Dr. Dutta, and Arti Srinivasan. And we hope that you're all staying safe and healthy at home. And we look forward to hosting many more discussions like these. If you'd like to learn more about the work of any of our panelists today, I'm going to drop their emails down below. You can also find more information on them in the event link. Follow them on LinkedIn, follow them on their website, wherever they're posting their research. You can keep up to date with their work and their insights. So thank you guys again once more. And to stay up to date on upcoming webinars, you can follow Hub Security on LinkedIn and on Twitter. And you can also check out our weekly digest on Medium.
Yeah.
So,
and Shterny, thanks to Ruby as well. He's in the background, but I think he's done a lot of work.
I was about to say that I mean, thank you, Ruby, for getting us connected and giving this platform.
Yeah.
Thanks, guys. I appreciate that.
Truly,
and following up, it was very helpful, by the way.
Sure. Thanks a lot, Ruby, Shterny, and David. It was thanks for hosting us, and thanks to all the participants as well. I think it was a great session, very informative and good interaction. I learned a lot of things today.
I certainly welcome this kind of panels. Will definitely help. I know this is the first one, but we're just scratching the surface, as I said, right? Having this kind of discussion at least stimulate new ideas, new thoughts, new problems, how we can solve it, right?
Definitely.
Absolutely. Yeah.
Very good.
Sure.
And exposes how much more I don't know. Every time you talk, you learn more that you don't know than you know sometimes. Appreciate it. It was truly a pleasure.
Yes, next time we need more and we can flesh things out more. So everybody have a good weekend.
Thank you, Shterny. Yeah. Bye, David.
Thanks.
Bye, Shterny. Bye, Buland. Bye, Shterny.
Yeah. Bye, everyone.